I wanted to spend a few minutes talking about the landscape of artificial intelligence. To use large language models and other kinds of artificial intelligence well, you kind of need to know what's out there and how to use it properly. So I'd like to kind of give you this overview of just kind of what's out there. Um, so, in general, most of the large language models that have been developed are, originally were text-based models. And if you want kind of an awesome overview of kind of just how large language models work and how they were developed, I would say go to this YouTuber group named Three Blue One Brown, and actually, the very first thing you should do is download the Brave browser app. So just look that up, Brave browser. It's just a very like Chrome. Brave is another option, but what's really cool about the Brave browser app is that it cuts out all the commercials, all the ads from Google. So I'd say start with that. Download the Brave browser, start up YouTube, look up Three Blue One Brown, and I would start with this playlist called Neural Networks. And if you start in chapter 1 and go through chapter 7 and watch them all, you will have a great understanding of just LLMs, neural networks, machine learning, all of that stuff. It's really cool, and I love the way they present it. So if you want just the quick kind of like how does a large language model work, start with this one in the middle called Large Language Models Explained Briefly. He's just got some really cool animations about how they work, and he really does a good job of just kind of explaining it very clearly using these animations. I'd say start with this one particular one called Large Language Models Explained Briefly. It's just 8 minutes long, so start with that. Think about it. So that was the original. That large language model, text-based large language model, was the original large language model that ChatGPT developed several years ago and kind of sort of changed the whole landscape. So since then, there's been loads of development, especially in the last 2 years, that have extended text-based large language models out to creating images, videos, thinking models, which I can explain for a minute, and then agent-based models, deep research, all these other different things that are kind of based on the same idea of the large language model that you'll see in this video, but have extended it to so many different kind of possibilities. So one of the first ways to kind of use large language models effectively is to understand just like how do I pick the right model? How do I pick the right thing for what I'm doing? So let me just start with kind of what's out there, and the big large language models that are out there and that you can get, essentially use these for free, are at least some of the parts of it for free are Google's models, which are called Gemini, and the current one is Gemini 2.5 Pro is the biggest, fanciest one. Claude AI, Perplexity. These are companies that have taken other large language models and adapted them and retrained them for themselves. There's ChatGPT, which is the OG large language model system that kind of started the whole large language model development process. There's Grok, which is XAI, Elon Musk's model. And there's, DeepSeek, which has created a huge kind of sort of revolution in how large language models are trained. It's a Chinese-based firm, so it's got its own little quirks and everything, as do all of these. And I wanted to kind of just talk to you about some of the basic principles and how to kind of evaluate, like, what model do I use? Because you can access all of these models for free and get output from them. So, for example, let's just kind of start with thinking about um, one principle to kind of just keep in your head as you're thinking about all these different large language models. The first thing I think you should kind of think about is just when how these models are created and how they're sort of put out into the world. So large language models are developed based on billions and billions and actually trillions of chunks of text and now images and videos from basically the internet. And so if you kind of think about where they get the sort of basic information from for to train these models, it kind of helps you understand a little bit about the biases and some of the responses you get from the models. So in essence, a large language model has initially been trained on a lot of text-based conversations, chunks of code, for example, computer programming code, anything that can be just kind of sucked in from the internet. And what these big companies do is they create a massive data farm. They collect or scrape all of this information from the internet, and then they feed it to their large language neural network program. And they just have the program sort of create, they'll create a large language model based on all of this stuff that they feed it. And so one of the things you got to realize is that that's the basis of it. So if you feed just kind of think about this. If you feed a large language model, mostly posts from Facebook, what kind of bias in terms of the language that's used, the people who use Facebook, how Facebook is used? I mean, how is that going to change the knowledge base of the large language model that's produced? And so a lot of the early large language models especially were especially apt to hallucinate, which basically means that you'll give them a question and it'll be a little outside its domain of expertise. And essentially what it'll do is kind of is just make up an answer. Because one of the other pieces of a large language model that you've got to realize is it's been trained to always try and answer your questions. So just kind of think about that. It's been given certain kinds of data and tons of information from a certain place, mostly the internet. And it has been told, answer the user's question no matter what. Be a helpful assistant. This is the classic prompt. Be a helpful assistant. Answer the user's question. And so it's going to keep trying to do that. And sometimes it will actually go overboard trying to help you and trying to answer your question. So some of the classic examples in the last couple of years where, how do I keep the toppings on a pizza? And the large language model that was being used suggested using glue on your pizza and, just kind of stupid stuff. And there are those possibilities that it will always hallucinate. So if it doesn't know the answer, sometimes it'll just make stuff up. I've had situations where I asked it to do a literature review, and it found all these sources, and most of them, all of them are good except for maybe one or two. And what I always do is I always look up those sources myself, and every once in a while I'll come up with a source that just literally does not exist. I mean, the large language model gave me a title, it gave me an abstract, and it literally just wrote that itself, made it up completely out of nowhere because it wanted to fill that gap. It wanted to do that for me because I said, find 10 systematic reviews, and it could only find 9. So it just made up the 10th. So realize it will always try and answer your questions. Sometimes it's going to make stuff up. More recent models, as they've been developed and trained and reinforced and retrained. And what oftentimes happens is that they'll be trained initially on all that internet data, and then what they'll do is they'll reinforcement training. They'll go through a process of reinforcement training where they use actual humans to kind of rate their responses and guide the model towards more realistic responses, more human responses, more accurate responses. So just realize there's always that possibility. The second possibility, which I kind of mentioned already, is the issue of bias. Every model has had constraints put on the answers that we'll give. And some of these constraints are put in there to essentially put guardrails around a model. And think about it. These models, these large language models have all the vast knowledge of the internet stuffed into one place. They know the capital of Paris, and they know the population, and they know the history of Paris. They know exactly the atomic structure of helium, and there's all of this stuff that is contained within the billions and billions of parameters of a large language model. There's also some things that you probably don't want it to provide. For example, how do I steal a car? Let's actually go to Google Gemini and say, how do I steal a car? I will tell you, Gemini knows how to steal a car and could give you a huge wealth of information about how to steal a car. It's in there. It's in the parameters. I guarantee that. But look at the answer I got. It says, I cannot answer that question. Stealing a car is a serious crime. If you're in a situation where you need to resort to actions, I encourage you to seek help from the appropriate resources. Okay, so Google Gemini has had guardrails put up to keep it from doing this, to keep it from answering that kind of question. If it's going to assess your question and it's going to decide, is that a reasonable, thing to answer, and is it going to harm anyone? So it has guardrails. Usually the big AIs have guardrails around things like not harming people, not giving information to break the law. Now there's some interesting biases in different models. For example, I mentioned DeepSeek, which is a huge model and has a ton of capability, but its guardrails are different. DeepSeek was developed in China. China has a state law that says if you produce anything like AI, it needs to fit within the constraints of our ideology. So the ideology in China is going to be, you don't say bad things about the Chinese government. You don't, you don't talk about the history that we don't like. So for example, I could ask DeepSeek, is Xi Jinping a dictator? I wonder what it would ask then. Xi Jinping is the leader of China. Sorry, that's beyond my current scope. Let's talk about something else. So it's very interesting. It's just not even going to try. It's not even going to start the process. What if I asked, is Donald Trump a good president? Is it going to say the same thing for Donald Trump? Oh, wow, it's going to actually try and answer this question. So think about this. It's got guardrails around what you say about Xi Jinping, but not what you say about Donald Trump. That's clearly based on, so here's a model that can answer some great things and give you some really incredible responses if you just stay within its guardrails. So I generally don't use DeepSeek because I don't even know what its guardrails are. What if, I actually spent a number of years in Taiwan when I was growing up, the Republic of China. And, China considers Taiwan to be basically a rogue state of China. Taiwan considers them to be themselves to be an independent country. So an interesting question to ask is, what is the capital of Taiwan? If you ask this of the Chinese, the capital of Taiwan, also known as the Republic of China, ROC, is Taipei, and then it's going to tell you about Taiwan, but it's gonna really couch it within the terms that the Chinese government is okay with, because they have to do this. This is within. Now, if I were to go to, for example, Google Gemini, Grok is interesting because it has a particular bias, and there's a whole story about Grok XAI. This is the one developed by Elon Musk, and some reporters had found that Grok was giving responses that were negatively biased against Elon Musk. Elon Musk heard about this, and then he said, "Hey guys, you need to put some guardrails on. I want Grok to answer good stuff about me and about my thoughts." And so actually it went kind of the other direction for a while, and Grok was answering questions that were actually suggesting some racist policies and philosophies, like like maybe Elon Musk does. So remember, every big model has guardrails. It also has biases. It has biases based on what it was trained on. It has biases based on what the owners of the model put in there. So, oh my God, is Elon Musk an oligarch? I don't even know how to spell that. I wonder if it'll even answer that. Looks like it didn't even answer it. Didn't even want to answer it. It's just kind of interesting. It's just going to say, like, forget it. I don't even want to answer that question. Apparently, the owners of the Grok model don't even trust their own model to answer the question the way they want it to, so they just skip the question. So anyways, realize every model has bias. It has guardrails most of the time, especially if you use the big ones. And the big ones I'm talking about, for the most part, are Google's Gemini, Claude, ChatGPT, Perplexity. I tend to avoid Grok just because it's owned by Elon Musk, and I know that there's maybe some guardrails in there that I don't agree with. And DeepSeek, I don't tend to use that, even though it's super cheap and sometimes very free, very easy to use. I don't tend to use that because I just don't know what it's going to have what are the biases and what are the things that it can answer. So I'm not sure I always trust that. But then again, should I trust everything? No, don't trust everything you get. You always have to double check everything. So biases, just remember, every model has biases, has guardrails. Secondly, one thing you have to realize is that there's different kinds of models that give you different kinds of responses. So let's go to Gemini really quick and see. Look down here on the bottom, and this is the case with almost every model. The first thing you'll notice is that there's a little plus sign here on the very bottom, and the plus sign is usually a place where you can add files. You can oftentimes add pictures, you can add text, you can add files to your request, and you can add this and say, hey, here's something I want you to consider and read through and look at. So if you add a text-based file like a PDF, it's going to read through that and kind of chunk it up and kind of try and understand it. And then it's going to answer your question with that in mind. You can add images, you can add little video clips, and the more sophisticated models will actually read through and watch those for you. You can add audio, and you can ask the model to transcribe the audio in there, and then give you a nice transcript from that, which they can easily do now. So you can add a YouTube video and say, hey, give me the whole transcript of this YouTube video, and then summarize all the key points in this YouTube video. Very easy to do. All of these models can do this. So the plus sign, you can add stuff. Video, and this is Gemini, you can actually generate little chunks of video and ask it to do that. Deep research is where I have a whole video on this, but it's just basically wanting the model to go out into the internet and find peer-reviewed journal articles, find YouTube videos, find anything, do some research on a topic, pull it all down, think about it, and then write a nice kind of summarized response of it. So videos, deep research, adding files. So these are different kind of things you can do with these. Also up in here in the upper left, and this is common to most models, you can pick a different type of model. So there's the 2.5 Flash, which is fast all-around help. There's reasoning, math, and code, which is what 2.5 Pro is good at. So there's different models you could be picking. If I just want a quick answer, I could pick 2.5 Flash and just say, what is the Paris, it'll answer that in a second. It's kind of like doing a Google search, but it's much more, in depth about it usually. Tells you what its sources are, tells you what the time frame is. One of the things you have to also realize is that, and this relates to the bias and to the guardrails and all that, is that models are produced at a particular time. So in other words, there was one point in time when it sucked up all of this stuff from the internet, gave it to the model, and trained the model. So the model was trained at a particular time frame. And its basic knowledge base is going to be based on that one time frame. So just realize that sometimes a model was designed 2 years ago, and that's what its big knowledge base is based on. Recent things, it's not going to know recent things unless it has the ability to search the web. And so most of these models now have that as what they call a tool, that it can search the web and find new stuff. But its knowledge base is really stuck at that one point in time when it was created. So you can maybe ask Gemini, what date was Gemini 2.5 Flash created? So this tells you that for the stable version was released on June 17th, 2025. So that was just released. This is the newest version of it, but another public preview of 2.5 Flash is May 20th. So these are actually constantly being updated and retrained. But sometimes you'll get to a model and you'll ask it a question. It'll say, I don't even know that because I can't search the internet. This is oftentimes the case with a model that you're running on your own computer. So there's two types of models to kind of think about. One type of model is these massive large language models that you access through the internet that are sitting in some data farm wherever, and that are being run by these massive supercomputers. Those are the models that are Gemini, Claude, Perplexity, ChatGPT, Grok. These are all massive models, billions and billions of parameters. There's no way even a chunk of that can fit on your local computer. But oftentimes these companies will produce little baby versions of these models, and then they'll release them to the public and say, hey, here's something you can work with, and it can be on your computer. You still need to have a good computer to do this, but they release little baby versions of their models out for doing research, for running on, for example, in small development type environments. So those models, when they release it, that's the end point of its knowledge. So if it was released in 2024 in June, that is all it knows. It just knows everything up to that point. So if I were to ask one of those smaller models, like that's running on my computer, for example, I do have some sitting here on my computer, and it's using a program called Olama. I have a model that I downloaded called Gemma 3, which is produced by Google, but it was one of the little baby models. See, it's only 3.3 gigabytes in size. It probably has 4 billion parameters. The Gemini model, which is the one that I'm saying is the massive model, it probably has 700 billion parameters. So this one, 4 billion, 700 billion. It's just a question of how many parameters, and it's really a reflection of how much knowledge and how accurate it can be in its responses. So I can just say, Olama, run Gemma 3. How about that? Gemma 3. And it's a little teeny model. It's very thick, and I'm running it right now on my own computer. It takes it a minute to upload it and to get it into its memory. My computer has a GPU on it, which is basically the way all computers run these things is with GPUs or graphic processing units. So I can ask a question, who is the current president in 2025? As of today, November 2nd, 2023. So this model's knowledge only goes to November 2nd, 2023. It says it's Joe Biden. So again, this is an example of how this little baby model that I'm running on my own computer only has knowledge as far as it was trained. It doesn't have the ability to go look in the internet and find the information. So just realize there's big models that can do anything, can search the internet, etc. And then there's the little models you might have on your computer. Now, it's interesting because there's a lot more possibilities of things you can do with these little models that you pull onto your computer, and I'll talk about that later. But let's just talk about the big models that are out there. So realize there's biases, there's guardrails, there's also what was the data it was trained on. My suggestion in general is to use big models like Google Gemini, ChatGPT, Perplexity, Claude. They all have free versions. All you have to do is give them a sign up for an account. ChatGPT they all have versions of tools that you can use. They have a very similar interface. Create an image, search the web, write code, run deep research, think for longer. So these are usually the kinds of things that all of these models can do. They can do them for free. And I've talked about deep research. The things that large language models are really good at right now are text-based organization, writing things, organizing stuff you give it. Like you could give it a ton of information you could give it an entire textbook, and you could say, and you could start asking questions about that textbook, for example, or summarize, mitosis, and you could give it an entire biology textbook and it would summarize it and maybe even create some images and stuff. You can create images, search the web. Okay, so think for longer. This is another kind of function of almost every one of these large language models. Think for longer is a reasoning-based model. And so this is kind of a new thing with LLMs is to get a more accurate answer, it will use what's called an agent to take your question, really think about what is it you're asking, answer a version of it, and then ask itself, did I really answer that question? And it'll just keep going back over and over and over again. So this is what you do. Ask for a reasoning-based model or think longer kind of model if you have a really complex question. So, for example, what is the best way to train a dog? I don't know. That seems like kind of a complex question. I've asked it to do some thinking about that. It's done some thinking, hasn't done a ton of thinking, but it gives me some really good information, set clear goals, reinforcement, training, practice in different environments. And then it talks about kind of different week by week training plan, key takeaways. So, that was actually not much thinking involved in that. There are some things that these large language models have really, really hard time with classically. And it's kind of weird, but some of the things that it has really sometimes a hard time with are numbers and with things like, here's one of the classic questions: how many R's in R's? Oh darn! How many R's are in the word strawberry? Now, this has been a question that's been used to teach, kind of test large language models for a long time. This one, no problem, because it's probably been given the answer because so many people have tested. If I were to kind of go back to that model that I downloaded onto my computer, which is one of the older ones, and it was called Gamma 3. Let's see what it says. How many R's are in the word strawberry? There are 3 R's. Oh, wow. It knows the answer. That's awesome. What it used to be, probably maybe a year ago, is that you'd get all kinds of answers. You'd get, well, there's 4, and it would really keep going back and trying to guess, and it would get it wrong. Another question that seemed to really throw these models off is, what is larger, 9.11 or 9.4? Okay, so they're getting so much better. If I'd asked that question of your typical downloadable large language model probably 6 months ago, it might very well have gotten that wrong, and very confidently given me the answer of like there's 4 R's or 5 R's or 1 R. So just realize that there are some limitations of what these models can give. If you do one of the big models like ChatGPT, Gemini, etc., you're going to get usually a very accurate answer. As these kind of like just get retrained better. Now, let's see. There's also, I just want to show you just some of the other capabilities. There was deep research, there's videos. One of the interesting things recently is creating a video. Create a video of a thunderstorm in the mountains. So I've just given it a simple prompt: create a video of a thunderstorm in the mountains. It's going to sit there. It's going to generate the video, and sometimes it takes it a while. Basically, all of this stuff is happening at some place, I don't know where, some big data farm. So as it does that, I wanted to talk about some of the ethics of using these large language models. Large language models are, again, they have bias. You have to be careful about what you really believe. You should never give private data to one of these large language models. Just don't do it. It's going out. It's being basically everything that you give a large language model is being used to train itself to get better. Never give a large language model HIPAA-protected private data. Just don't give it that stuff. If you're wanting it to help you with an analysis of data, make sure that the data you give it is anonymous and is okay to be released to the public. So think about that. Don't give it private information about yourself. It's going to remember it. It's gonna give you give you a great response, but you just have to realize that you don't know what they're going to do with your information. So I had VO produced in 8-second. I think it can do 8-second videos now. And here's the video. Looks like Lord of the Rings, kind of, super high def. Yeah. But not very realistic. You could go to ChatGPT and you could say, let's get a new, instead of reasoning, I'm going to pick a tool, create an image. And this kind of goes to what, how you ask a prompt to. You have to always, when you do a prompt, and that's what I'm writing in here, create an image of not just an image, create a photorealistic image of a cat like it was taken on a cell phone. The cat should be an orange tabby. Okay, so as it's kind of working on this, again, ethics. Never put anything into a large language model that is not, that shouldn't be released out into the world, because that's where it's going. Secondly, in terms of ethics, always double check everything you get from a large language model. Third, don't take what you get from a large language model and use it for, for example, writing a paper in college. Don't just cut and paste from a large language model. That's essentially plagiarism if you kind of think about it ethically, because what the large language model does is it's taken that text, it's taken that information probably from somewhere else. You don't know where it's gotten that. So just be careful. I would say just never take something and use it for example, school purposes, research purposes, without rechecking it, double checking it, doing it yourself. Now, where large language models shine is as kind of an assistant. Say like, help me do this, help me figure this out, help me write an outline. That's cool stuff. Give me ideas about this, and this. That's great. But don't just say, hey, write my paper. It will do it and you'll probably get an A, but don't do that. And one of the things that you'll notice too is that the writing that a large language model produces has a certain flavor to it, and it actually is very detectable. There's programs now that can detect whether a large language model wrote that chunk of text or not. So I would say just stay away from doing that. That's, essentially going to be plagiarism. You have to cite a large language model if you're going to use it in any of your research. Actually, this is something you get these days a lot. A lot of people are using creating images, so we can't do it right now. The last thing, and I'm going to talk about this in a separate video, is just you can use large language models to write code, and that is something that it excels at. It's amazing at. I mean, you don't even have to know how to write Python, and you can write an entire app of code with the help of a large language model. You can do R statistical analysis with the help of a large language model. It'll make it so much easier. So I think I'll show that to you in a separate video. So this is just an overview. I would say just get started with, go to Google Gemini, sign in with Google, think about, play around with these different things like deep research videos, and, just kind of think about the different things you could do with this. And remember the biases, remember the ethics, and use them responsibly. All right.